Hi. So I hope you have a good weekend. So let's return to our exploration on the random variable. I think we rushed over the discrete one. Today we will talk about continuous. But before that, let us review what we've done, because I guess if you learn it for the first time, it is not easy to digest. It takes some time for you to really appreciate what we are doing. And after that, we will, because the learning, understanding of the discrete one will help you to have a sound foundation for the continuous, and which is very important under the bell curve for the idea. So actually, this part, I think we study in a great detail that, why don't go away? Yeah, is the idea of random variable, right? Just to reiterate why we need that is for two reasons. One is the sample space is usually very big, right? The number of the way of the outcome, number of outcome, depend on how complex you want to describe the world, right? Can be very complicated, and we usually interested in something we can have number on, we can measure, right? Either it's integer, you count 1, 2, 3, 4, 5, or a number, the stock price is in price or money or profit, this kind of thing can be measured, and it's something that we'll use it as in business. Often time we deal with numbers, right? And there's some reason that we need to disaggregate our study on random variable on two things. One is discrete and continuous, because of the fact how you handle the infinite number of outcomes, right? Because discrete is, you can allow countable, right, as a Poisson said, but still a countable. When it's uncountable, then you really rely on something that we need calculus, okay, which will become more clear later, okay. And just to remind you, the very old example that we told the coin once, and you can be head or tail, and then we are not interested in the exact outcome, but number of head. That means that we will actually make the number of head is the thing we care, instead of simply head or tail. So then it will basically tell me that the outcome is head is mapped to or connect to 1. You give me tail, then it's 0. Okay. And that means that we're doing counting, right? Because when we extend it to toss a coin twice, okay, then head means 2, tail head or tail head means 1, and tail means 0. Okay. And same for continuous, which we'll do more about today, okay? And for random variable, for discrete version, okay, the only thing we need is to perfectly describe it, is to give us the probability that the random variable can take, right? So because the random variable can only take discrete, means number you can count. So basically, you can tell me that for each value that the random variable can be, what are the probability, right? That give us the bar graph we have here. The left-hand side is the bar that tells us the height is the probability, right? The big P. And we also learned the big F is also the way to describe the same thing, right? It's not just the probability, but we calculate what is the probability for the random variable equal to that and less than. It will be clear when we talk about continuous today, because basically just stacking. And later you will see why we have to. It only makes sense to talk about big F when we have continuous random variable. There's some reason why we have to do that. The reason is probably is not defined. When you have many numbers, right? And if you have infinite numbers, there's no value that can be all 0, right? If you look at the continuous random variable later, you will see the Px will be 0 for every number, right? And in general, it's like this. So that's why big P is not a well-defined concept here. So, and this is the wrongly die, right? And as we said, the big P and the big F are a good way to describe the process we want to study. The problem is still the big P and or the big F is very complicated analysis, right? I mean, probably when you talk to people in investment, right, you tell them, okay, under this scenario, make this much, under this scenario, make this much, under another scenario, you list them 20 scenario, then people attention will be loosed, right? And you can't really get attention to give them a very perfect description of what you think about the world by P is not easy. So usually, as in investment, right, we look at the mean expectation, right, which is what a possible value, but you would weight it by the probability. If you want to talk, maybe you can keep your voice down a little bit. Yeah, if you want to talk, then please keep your voice down a little bit. So if you know the expected value, then probably you would know the property linear. This will help us to save our lives because we do not need to worry when it's a multiple of the random variable. Okay, we can normalize things, right? Because we don't need to focus on, say, the investment profit. Just focus on return, rate of return. Okay, and similarly, look at the mean and you also look at the variance, right? That would be the definition. Then you should know how to calculate that as well. The formula, then you have to be careful when the variance have to be multiplied constant will be constant square. The reason is being with the square in the variance. Okay, and there's something we just briefly brushed on, but we didn't go to that detail. Is it's by very random variable. Okay, and the fact that regardless of the independent, this expectation, the linear property will still hold, right? That would be, doesn't really matter x and y related or not. Okay, the expected value of the sum is sum of the expected value. Okay, and if they're independent, then you have the variance, sum of the variance of sum is sum of the variances. Okay, so we can decompose it, but the thing we didn't go into detail is here, right? The special term here is covariant xy, which said if x and y are related, okay, the variance will be different, okay? And if it's positive, the variance is larger. Actually, that feed, if you try to remember it, then it will be actually you learn in finance. Or investment, classical wisdom of don't put all the egg in the same basket, right? To put the egg in the same basket, the covariance is positive. So it will be larger. Right? If you spread the egg in different basket, then the covariance is negative, right? Or zero, if you like. It depends on how we model it, but it's not going to add more risk, right? So that would be something that you have learned. So in the last class, we learned these 5 different distribution. The most useful one is binomial and Poisson. I mean, uniform is also useful. Others are just to illustrate what you might learn from that. Okay, hypergeometric is more or less. I mean, of course, it can be applied into a lot of quality control and audit, because that is, if you recall, that is called sampling without replacement, right? And binomial can be considered sampling with replacement. But let us quickly go over that again, and then we go to continuous distribution today. So uniform distribution is the worst first thing you try to model if you don't have any idea, right? If you have no model, that is the model you want to use, right? Unless you have a big idea what are the outcome, how likely each one they are, then you would be using some specific model. If you don't, this is the first model, and probably you will say, okay, how do we go ahead from that? That is by Bayes rule, right? We go on this prior. You start with uniform for each possible outcome, and use Bayes rule to update and keep updating. That's how we learn the real world, and that's why science do another experiment, you know what might be the outcome, right? Then you just keep uniform and you keep doing this thing, right? Because suppose as a medicine, right? If you feed the medicine to a patient, there may be many possible outcomes you can get. I mean, find a number of them, and then you can assign equal likely. And by keep doing this experiment, you learn which are more likely than others. And at the end, you get the model that really you need, right? That's what we mean by machine learning, right? Or human learning, also the same, right? You just keep learning what are the possible outcome will arise, and uniform is the very starting point. Okay. And the next one is called the Brunoni, because this is the very first one. Then when we study discrete, and no matter what textbook pick up, this is the first one you learn, because this is a basic building block, because you would consider the world it's either one way or the other. It's either success or failure, right? The bipolar view is very common. I mean, in US, right? Always left or right, right? Or either you're conservative or progressive, or in the world, it's always one way or the other, right? This is the standard one, right? You would have, of course, to describe this is very simple, right? This is the description, right? This is the world we want to look at, right? And this is the probability distribution and the mean and variance. That's, I think we explained it. There's nothing very deep here, right? But the only deep thing here is the binomial, right? The binomial is you have Brunoni n times, each time independent, right? But independent means we can study them separately, right? So although we call this univariate, but we allow adding up, right? Because x you can consider is x1 plus x2 plus add to xn, right? Each xi is actually Brunoni, right? And we explained that this is the function we call the NCX, right? I mean, because of the way that how success is being done, I mean, that with the formula. As I said, our class are not math class. So if you don't understand the logic behind, then just take it as given for you. Of course, there are many YouTube explain why it is true, okay? But I'm not expecting you would, I mean, I explained already, but it's okay if you don't get it. It's not a necessary condition for doing assignment or the test, okay? I mean, of course, good to understand it. And there's formula, mean, and variance, okay? And for technical note, you may ask, why we care about the mean and variance, right, for the model, right? Because with the model, the mean and variance can easily calculate, right? And one reason, okay, that this mean and variance formula is useful is the fact that if I told you I want to model something by binomial, by the data, okay? You know that, okay, there's a process, actually it's a follow binomial, right? Because like suppose you can model number of people coming in is a binomial, right? Or how many tables people like spicy food, right? And in the example, actually, you see, right? For example, this example, right? And we have 30% people like spicy food, right? And how do you get this, right? It's actually coming from data, which is NP. You map this NP. From the data, you get the mean, you get the variance. And going back, you guess what's N, what's P, right? So that would be one of the reasons why how this formula being used. That is called the method moment, but we're not teaching this in our first year level, but you learn it when you go beyond why this formula needed, because this can help us to guess what are the N and P, right? Try to model. This is very commonly used in science and engineering, because we know certain thing come from physics, it would follow binomial. Okay, it's less likely in business, but you still see this is something reasonably applied, right? When you think that what you want to study is combination of n different part, and each part has similar success probability, then there's something we can do, right? It's like in finance, right? You look at like how many days the stock price go up and go down, and this is something you care, right? And I think the example here is about the spicy food is already way business oriented. Okay. And this is, if you look at this as an inventory management, right? And this is very classical application. Okay. And I already show you so many applications, so I don't think I really need to go to the detail. Okay. And next one, this is, and you can consider this a special case of binomial, right? Because binomial is what you have n different box, right? And each box is the same, and the box, each box you open it has some probability success, and each box success probability the same for each box, right? The n box, each box is success probability p, right? And now consider the case we have n, so many n, but p is very small, right? That's, it's the same to apply to the case we have timeline, right? You cut each time interval to very small, right? Then p is very small, right? And when n go to infinity, the binomial will be collapsed to the same, it's no different, right? It's n xp, but when you can solve the math is when n is big, p is very small, then it becomes this ridiculous formula, right? Where e is a number, 2.6, 2.713, okay? And that's it. The denominator is factorial, is a multiplication, right? It's integer. When x is integer, you just multiply 1, 2, 3 up to x. Okay. So that would be the formula, because you will see n, p always appear at the same time. So lambda will be the only thing we care. And lambda is the mean, right? And what's the mean of the lambda, right? Look at, remember, is the n times p, right? N is the interval, p is success, right? It means per unit of time, how much success you got, right? So lambda is equal to 1 means the whole period, you expect one thing to happen within this period, right? So that's why when you look at the example, okay, you will be, say, if I'm expecting 5 customers arriving each hour, so the lambda will be 5, right? You can just put that in. Shouldn't be particularly difficult, this one. Okay. And the very last thing we study is closely related to the binomial. Binomial actually means we have n boxes, and each box is dependent. So what you pick, the first box doesn't relate to the second one, right? But very often we face with the idea that we are doing sampling without replacement, right? You can imagine the binomial is saying that, okay, I have 70 students in the class, out of which, say, 60, 40 of them are female and 30 are male, right? Then if I try to draw 10 people to participate in a competition, right? Then it's a binomial with n equal to 10, right? And then p is, if female success, is 44/7, right? And for binomial, it's modeling the case that I draw one student from the group, from the group, right, from the class, and I put it back, right? It's possible to draw the same guy or same girl, right? Then it's put it back. If I only allow us to draw and don't put it back, right? If I draw one girl, then you become 39 girl over 69 student, right? Depending on what I draw, right, it's gone, right? So this is the idea of drawing with replacement, right? The notation which we use is to follow the Excel formula, is you have big N of items, out of which A of them are good, okay? Good item, good maybe success item or defective or whatever, but just the thing you care, okay? And big N minus big A is the thing is not so good, okay? And the question would be, if I close my eyes, I go to draw small n out of this big N, okay? The question would be, how many x of them is come from the good item? that because it's bipolar, right? So x is good and n minus x is not good. Okay, then how likely that I end up with x, right? So the way to do, which we don't ask you to produce the math class, but it's just this idea of combination, right? Because you have n item, you pick n out, then it's NCN, it's denominator. Do remember that when we do this, it doesn't count the order. Okay, of course you can use P, but there will be no difference. Okay, and the way you pick in the denominator is you have to, it's a principle of counting. You have to do one is good, one is bad, right? So it's two ways to, then you do multiplication. And how many ways you can pick up the right thing is A, C, X, right? Out of A good thing, you pick X of them, right? And N minus A is the bad thing, bad out of the bad, right? N minus X. So this is formula, okay? And as I said, you don't need to worry about the formula. This is the way because, as I said, there are more than at least hundreds of distributions. You can't really try to make sense of what is one, right? The only thing you need to know for your moment is look at how the P looks like, look at the shape, right? And look at what the mean and variance offer you, right? And that is how you do the modeling, right? Because at this stage, you're not asked to figure out that, okay, besides what we taught, right? Are there any distribution that fit your model better, right? I mean, of course, in your work, right, you have to figure out of, say, more than hundreds, which one works well than the others, right? But in our class, we only focus on 5, so then you just pick up the one that fit the application, right? But that will not be difficult, right? Because when you figure out that there's n component, each component is independent, then it's binomial, right? If dependent, that's geometric, right? And about time, there must be Poisson, right? If no idea, then uniform. So it's not something like to be very difficult. And usually I would give, well, under no, I think in this class, under all the circumstances, I will tell you what it is, right? I will tell you this follow what distribution. So you don't have to figure out when to use what. I mean, you know, it's given to you, you look at this page and then just apply the formula. That would be something we ask for, right? You're not asked to, I give you application, you figure out what it is, and you will be given what it's about. Okay, I would say, if this follow distribution, what is the mean, what's the variance, what's the probability? So this is the thing I ask, okay? I'm not asking you to say, this application, you have to use this and that, but that would be maybe a little bit difficult for you. But it will be there when you look at more advanced class, okay? You don't worry about, you can't distinguish, but as I said, this is the most important, right? The purple thing is you need to remember, right? The green thing is you need to know how to operate, and that's it. Okay? So your final test will not be too much different from your assignment. I think in general it'll be easier, right? So that as long as you know how to do your assignment, shouldn't be an issue. Now, I think we've done that as well. So I hope there's a good review of what we have done, okay? Just to make sure that you understand all the blue, purple box, you know what's going on, and over the green thing, you understand how things being applied. If you're okay, then you go to work on the assignment, then it shouldn't be an issue for you. Of course, there'll be quiz, self-check quiz at the end of, well, after we finish this, we'll release the quiz too, right? So just for, yeah. So you can do it on Friday because Friday is a holiday, right? You have fun with the quiz. So we now go to continuous random variable, okay? And later you notice that the famous bell curve is there, okay? There's something we learned in the central thing is bell curve. And also the other distribution is related is exponential, which we will talk about in more detail later. And that is closer to the Poisson with the idea we said, right? Poisson is saying what? Poisson is asking within an hour, say, how many customers will arrive, right? And sometimes we care number of customers arrive, but sometimes we also care when the next customer arrive, right? the time until the first customer arrive is exponential. Okay, that is something we want to study. Okay, so basically it's the exponential and the normal, the bell curve. That's what we want to study mainly today. And you look at the slide, you notice that in this slide I also talk about P, chi-square, and F. That will be something we'll use for the second half of the course. But just put it here to let you know what maybe they are, and because we'll talk about them. But that is not the full focus of this one, because we will use it at the end. We will in the second half of the course. Okay, because out of this slide, the first half of the course is over. Okay, I mean, of course, we are not in the way before. I mean, just only the 4th week, but I think we are on a good timing, good schedule. I mean, it's not delaying anything. Okay. So let me repeat why we need different tools for talking about continuous random variable. The reason is the Px will be 0 everywhere. Okay, we will make it precise what, because Px is what? Give me the number, you tell me probability, right? And suppose you try to model the stock price, right? Say, suppose the Hang Seng Index now is like around, say, 20,000 to 30,000, right? If you try to model any distribution, right? Any number is possible, right? Continuous, right? So if you try to put any number, positive number in terms of probability, right? You add up infinite number of them, it will be more than 1. It violates the ideal axiom 2 or 3, actually, right? Because you add them up, it becomes infinity, right? The infinite outcome. If you try to put something positive, right? Add them up, you blow up, right? So you can't really use P. It's not possible to do it, okay? You have to use big F, okay? But you may ask, okay, do we have something still like P? Yes, we do. That's called the density function. We will define it slightly. It's technical, but we just put it there, and then you will know. And with some integration over here, but just bear with me, okay? So we call this example, if you remember what we have is the kindergarten problem, all right? Pros and cons equal likely. Then you have number of head is either 0 or 1, right? This is head and tail equally likely 1/2, right? And then we stack them, right? Less than or equal to 0 is 1/2, less than or equal to 1 is 1, right? And we will use this one to describe, because it will make sense in continuous, right? You can't really make sense for the discrete. Okay, but let's see what we mean by that. Okay. Say, look at the other example. Okay. If we look at the uniform, if we still recall, uniform is each number is equal likely, and uniform between 0, 1, and 2. Okay, it's 1/3, 1/3, 1/3. Okay. The big F is stack them up. All right, stack it up. All right, I think you can go from the left to the right. Shouldn't be an issue, right? I think at this point of time, all right, shouldn't be an issue if you try to, you just stack here, you get a 1, and you stack 3 of them, you just 3. Okay, that shouldn't be an issue. So the question would be, you notice, okay, is as you increase the number there, okay, this is still fine, it's go up, okay? A straight line. But you can see this is, the height will be 1/n, right? If you have 3 here is 1/4, right? So on and so forth, right? You're getting smaller and smaller, right? As you infinite number of them, right? As big as you want, it may be 1,000 or 1,000,000, this will be so small that no longer meaningful to talk about this P. So that's the idea, all right? So that is the idea that why we can't really go to the P, because when n go to infinity, then everywhere is 0, right? It's uniform, say from 0 to 100, right? Which will be your final marks, right? At the end of course, right? It's either get 0 or get 100, right, from the course, right? If you try to model it as a uniform, right, then every number will become 0, right? So how can we solve this problem, right? As we said, okay, if P is not defined but F is still defined, then it's okay. We just define F, right? Because F is still defined uniform, it's just still a line. right? A 45-degree line, right? If you look at this, this uniform is a 45-degree line here, right? Just this one becomes very small, and then the line goes up, right? And so you will be losing this for the rest of course, the big F. So you will be familiar with that, okay? And do note that, okay, because of the axiom 3, okay, this you will know very well, okay? It's this guy, okay? You will know this very well. The probability between A and B will be F of B minus F of A. The reason is very simple. You just move FA on the other side, right? This axiom 3 tells us, right? Less than B will be up to A and A to B, right? Because this axiom 3, right? Less than B, right? You can divide in two parts. Everything up to A and A to B, right? Because everything less up to B, right? B is larger number, is everything up to A and between A and B, right? So that gives you this one. It's coming from axiom 3, okay? And this one is complement rule, right? Bigger than B, right? Probably up bigger than B is 1 minus B up to B, right? Because less than B and greater than B, they add up must be 1, right? Because that is coming from axiom 3 and axiom 2, right? Axiom 3 said adding up, right? And axiom 2 is sample space, but this is just complement, right? Because less than equal to B and bigger than B are complements. So this will be used very often. Okay. So I want to put this technical, but I guess I still need to define it properly. So if we want to have some probability between A and B, okay, although we cannot say probably equal to a particular number, but we want to say probably within interval, right? And we know this is actually from the last slide, right? This is indeed what? This is FB minus FA, right? Right. FB minus FA. But the question would be like if you learn calculus, there is called the so we would like to say, right, when suppose this F, right, this X is over A and B, okay, and I don't know how it looks like, but can be anything, right? So what I'm going to do now is, right, this F of B, maybe I use a bigger screen to give you some idea, okay? So this is X, this is F, right? And this is A, this is B. I don't know how it looks like, but at least it's going up, right? Because the probability less than A, less than B, then must go up, right? So the question is, this is F of B, this is F of A, right? And the difference, right, is given the probability that between A and B, right? And okay, is there any way to make it easier to understand? Okay, this is B minus A, right? And is there any way to estimate this guy easily? And we can use linear approximation, okay? If this is A, B minus A, okay? If I try to draw a line, the slope is I call f of, say, some number x is between A and B, right? And this height will be fx times B minus A. You can, x is somewhere between B and A. Why this is true? This is a math theorem. It's called the, I think it's called intermediate value theorem, or the mid-value theorem. It's saying that and f actually, the small f is actually a derivative. And if you can think f is tangent at fa, right? This is basically the slope, right? And if BA getting smaller, then this approximation is accurate. Okay, so actually it's calculus thing, right? If you see this graph, it's actually calculus. But as I don't want to talk about calculus. If you understand, it's okay. If you don't, that's okay. I mean, I don't want to bother with calculus. But that's the idea why I write in this way. And you can rewrite that B minus A is delta. Then you can rewrite in this form because you divide B minus over here. Okay, and that means that this is density if you learn physics. All right, I don't want to talk about that, but because the physics, so that's why the density function. So that is a calculus. When you take the calculus, that is something we want to work on. But as I said, I don't want to bother you with the math here. Okay. So, but the thing that we want to tell you is why we still, maybe we have good difference of f. Okay. Then why we still care about small f? Because it's very convenient. And actually, this is the bell curve that comes from. The bell is not about the big F. The bell is about the small f. And because how the calculus is being derived, so when you look at the small f, which is the slope of tangency of the big F, okay, and the probability is just area. Okay, so I talk about something super crazy. Maybe we organize what I am saying. So let me have another slide. Okay, suppose I have some x and some f. Okay, I have some function, I don't know, go up, right? And if I want to have the probability that, say, x is less than b and a, right? So what I'm going to do is look at this a and look at this b, right? And take a difference. That will give me the probability, right? That would be something that I need to know, right? But we often, of course, this is doable, there's no problem, but it's not very direct. Later we will see it's more convenient not to look at the big F. Rather, we look at x and small f. Okay, the small f can look like any shape. Okay, and by looking at a and b, this is something the same as this height. Okay, and what are these values? Okay, here, say what is this value here? There may be a point C here, right? What is this value here? If you learn calculus, it's very simple. Point C here, I look at the slope, I calculate slope here. This will be the f. So this is a calculus part, but I don't want you to worry about calculus part. So what you know that is there's big F, there's F, they're related in some way. If you know calculus, if you differentiate F, big F, you get a small f. You integrate the small f, you get the big F. But I don't need calculus. Okay? So only you need to know there's a big F and small f. because the computer gives you this. Okay, don't worry about how you convert the other. Okay, the idea is just the slope. Okay, and if you learn calculus, if you integrate, that's area. Okay, so that is the only thing you need to know for a small f is the area under the curve between A and B will be the probability in A and B. That's the only thing you know. Okay, let me repeat the most important thing you need to know from the small f graph. What you know is the area under the small f graph between A and B will be the probability between A and B. That's it. Okay, that is the only thing you know. Okay, that is the only thing you know is like in this area is this guy. That is something that we will use for the rest of the semester. Okay, you know this and then you're done. Because basically this is the thing we need. How we connect. Okay. Although I know this is something that totally mathy, because you don't learn calculus, it's very hard to say. But big F is the description of the world we know. And you can always do big F, right? But sometimes it's more convenient, right? Because to look at the small f. Because area under the curve is the probability, right? Of course, you can take a difference between the f. It's still the same thing, okay? I look at big F of B, big F of A, take a subtraction, it's fine. But this is more direct. So that's why we look at this one. Although this thing intuitively more difficult to understand, but explanation-wise, small f is easier. Okay, density plot is easier. So look at all the textbook, they use the small f. Okay, it's not my invention to look at the small f. Okay, but big F is well defined, and it's beautiful to look at big F. Look at small f. Okay, the small f is if you don't want to do calculus, it's slope at each point. Okay, will become the small f, and the reason is the calculus, right? Because the theorem actually is related to the, I think it's called intermediate value theorem. Yeah, intermediate value theorem is defined this way. Okay, but I don't want to go to the mathy part to say, okay, this is right or wrong. But I mean, don't worry, you will see the example, then you will see how it apply. Okay, as I said, it's not a math class, so I can't really expect you to know the calculus. Okay, but at least I know, I hope how you convert from big F to small f, right? The idea is the big F is well defined because it's probably less than that number is the probability, right? And we want to transform the small f, which is common slope. You don't have to know how to transform, but f is given to you. But anyway, the only thing you know is the area under the curve is the probability. That is the thing you need to know, right? You don't need to know how big F comes from small f, right? But small f gives us the probability directly, looking at the area. Okay, so I hope it's not too much to absorb. Okay, so basically say this, the first graph, f of A, this will give us a probability that the random variable less than or equal to A, right? And 1 minus f complement will be the probability that Z is greater than A, right? And this is between A and B, right? So it's just the area, okay? And this bell curve, we work on it for the rest of the semester. So it's no way you don't understand. So don't worry about it. If you don't feel comfortable with that, it's okay. Because as I said, we do for the rest of semester for this way. Okay. I'm not going to explain integration. Finally, one thing I want to tell you before we break is, as we said, is continuous random variable. So the probability equal to a particular number is 0. So whether we write the inequality side with equality doesn't really make a difference. Look at the last 4 bullet points, they're the same. So that's why we are very loosely to, we don't focus on equal to what number, okay? But they are all the same for our purpose, okay? Do note that this is for our class, okay? And it's possible that there will be maybe some probability mass somewhere. Then they're not continuous. They're called mixed distribution. But continuous by definition, they must be 0 for every single point. It's pure continuous. You have some mix, you have some mass somewhere, but it's not our goal to study those. Okay. And but maybe I end with this crazy slide before the break, is you can define expectation and when the same, okay? And it's involved integration, but you don't need to worry about it because I'm not going to ask you to do any integration or what, okay? The intuition you have from discrete carries on. That means that mean is just simply, you can imagine our life is, you just run this experiment many times. Every time you have the value there, average of those is the expectation. Same. Okay? Everything just continue because integration, the summation for infinity. Okay? But I don't want to bother you with that, but I don't want to put a black because you have to know what it is. Right? I mean, you don't have to do the calculation, but there's something that's behind, right? There's a big small f that's in front of there. Same for the variance. As I said, when calculus is not required for our class, but I need to tell the definition, right? Other than just hand waving, but everything is the same, just the mean, okay? Just the variance, okay? After the break, we have fun on these distribution. Of course, we are not going to finish them in a one shot, right? So we will finish all this on Wednesday as well, okay? So just we take our time, we finish that, and then Wednesday we'll come back and do the rest. But let's a break of 15 minutes. I know it's a lot to cover, so that's why I open the U reply. You can tell me which part that you need me to discuss more, or which part you need me to go faster, right? Then it'll be helpful. If you see there's something you don't understand, please feel free to ask me when I go around, or you can leave the comment on the U reply. I'll see you in 15 minutes time. So resume at 12:35. Sorry, 2:35. Sorry, 2:35. But can you explain why the slope and point I get when the slope is derived at the same time? That is what we call the fundamental that's divided by Newton. Really? That is the nature that no way that they are very mild as well. This was B. This will be distance, right? And the area under B is distance. Yeah. But then how could you sum up all the students of the different problems? Yeah. So then the change in probability is the additional area underneath each curve at every little teeny point. Yes. That's how it is. Adding on the bottom. That is. Thank you, Chris. That's a good explanation. I want to like make sure I know it's really solid. Yes, but that is common standard. People understand integration. Area of the circle, cylinder. Yeah, that is why people start. That is what people do this. The energy yeah, because like like it was easy to think about it, like in terms of like speed, like, but it's hard to think about it. Yeah, definitely, that is something. It's not that like, but that is a problem that they are like when you it's one of them. Yeah, I know. My teachers, they train like know the calculus well. That was the first part of calculus. Patience. We will see all the integer, the real number. Oh, I mean, that was that quick. We can take integration, learn something, even like understand. Yeah, it was limit. Only before that, they don't even understand. They don't understand. Like a hospital. Yeah, they don't understand. It works anyway. Yeah, I think they don't really works. It's just a math behind the equation. How many? I need to brush up on my math, but this is a good start. Yeah. I think, when I see the things I was guys, I know what you're talking about. I just got my tricks. Yeah, it was just good, but I mean, that's my positive point. No, I appreciate it. I know this small hand that pick the others. That's a small app that okay, the area is probably the thing. Yeah, it will be good enough for the final exam. Yeah. I hope that is satisfying. Yeah, I did. Well, I wanted to, and I took the test and I placed that. So even though I did very well, I did tell people who were I think maybe that something like that's really good. Yeah, I mean, like the calculus we did, like we did 2 classes. First one, really all derivatives, and second class, where calc 2 was all integration. Like we did things like up to spinning objects around and stuff. And I found like it wants to know. Yeah. But it's not very like okay, this is what I mean. In the middle of the case, it was like give you like a sheet of 100 problems you had to solve. I mean, yeah, no, that's when I started. That's why I thought speed. Again, I took a physics class too, where we did like derivatives and well, I mean, it didn't require
requirement you can kind of achieve by doing derivatives instead of like, adding up all this.
But you need them when you have well, you don't need the calculation. You simply mass equation.
Oh, yeah.
We really need the derivative for
Yeah.
Everything makes fine. Right? It's saying that we say there's a momentum, right? Everything. Yeah.
That's why memorizing can only get you so far. Understanding how to base up.
That's why I think I'm trying to explain intuition that is most important for any formula is all in there. Way more. I want you to have the cause is and then not in person. But it's like
yeah, try to know things. Yeah.
Know things what is slide. But good, I mean,
Thank you, Professor. I appreciate it.
anything that comment.
So let's come back and see what a comment you have, and I try to see if I need some adjustment to be faster or slower. So we have 20 student writing. Yes, it's very good to understand continuous random variable because that is the bell curve is actually continuous, right? The thing that we actually use a lot of time, the bell is continuous. But as I said, the bell curve is very similar to binomial, right? With p is equal to 1/2 and n is very big, right? Not so big, but n is big enough, not too small. Yeah, just one thing that I mean, if you want to top is keep a little bit the voice a little bit down so that other people can concentrate. But I hope that would be what's limit, okay? Limit is a actually math idea. Say, okay, to talk about limit, then I have to give a very simple idea of limit, okay? So the limit, okay, we can see in this example, right? We have two outcomes, right? And it's 1/2, 1/2, right? And then you have three outcomes is 1/3, 1/3, 1/3. You have four outcomes is 1 quarter, 1 quarter, 1 quarter, 1 quarter, 1 quarter, right? If we have five outcomes, is 1/5, 1/5, 1/5. And then when you go more, then in general, 1/n, 1/n, right? And limit means that when it's so big, right, and it's go to very big, then it actually becomes 0, 0, 0. That's limit. There's nothing called infinity, right? It's something that go to very big, then it's very similar. Okay, so that is the idea. Limit is like it's not exactly we're there, but it's just like we think about a process. It's going so big, then it's become 0. And the limit idea, if I allow me to say, limit is the idea that for mathematicians, they don't understand for a very long time. Okay? If you look at history, even Isaac Newton or Leibniz, who invent calculus, actually he didn't understand limit. Not until Cauchy and the others figure out what is the limit definition. Limit actually either you go to very big or very small. That's how we define. Okay? Or to give you an idea, the limit is it's a little bit math, okay? And I hope everyone would understand this concept, right? If I circle, right? How to calculate this area, right? Circle, if you learn actually before the everyone in the world, I mean, every history will know is pi r squared, right? R is being the radius, okay? And the question is why this formula is right. Why? Right? It may not be surprising to everyone, right? If you learn from the primary school, right? How do you prove this guy? How to prove this guy, right? The idea is being that what you're doing is, this is a center of the circle, right? You just try to draw a triangle, right? And the triangle, if you cut many, many small pieces, then you have a one circle, two triangle, and so on and so forth, right? There's a bunch of triangle, right? And the triangle, you can consider it so small that become a rectangle, right? The height of the rectangle is R, right? And what is this length, right? If you recall, the circumference is 2 pi r, right? So that means that I have two-sided, this is pi r and this is pi r, right? Because 2 pi r. So the area is pi r squared, right? And what are you doing here, right? We cut it into triangle, many, many small triangles, right? And this will be right if we can cut this triangle small and small, so small that it can't be smaller, right? But of course, you can always go on. But you keep going doing this, but there's no end. So in the limit means that you keep doing this, there's no different, right? You keep doing it, then it's called the limit. Means that we are actually not there, but we keep doing it so small or keep going to infinity, then that is something we call limit. Okay, I'm brushing here, or I'm hand waving here, but that is what limit means. Is actually it's very close to it, but we don't really get to it. It's a way in math to handle this kind of problem, infinity, right? Because there's nothing infinite, right? Because we cut to many infinite number of triangle, right? But the idea is no matter how big the number is, it's getting closer and closer to pi r squared. And at the limit, that is right? Because you're getting closer and closer to pi r squared. So that is the main idea behind how we prove that. How to formalize this, you have to go to math class, right? I'm not going to show you that, but it's a very complicated problem, as I can say. And I hope I answered the question, because to make you happy, I mean, we don't do limit in our class, okay? Limit, you understand, it's fine. You don't understand, it's okay. Okay? So he said, if you understand, if you don't study, then you get a bad grade. I cannot say that, because in this class, we introduce a lot of the concept, but just for formality or to understanding, because it's definition. But what you need to know is the green box. Green boxes, you know, then you're done, right? I'm not asking you to understand, okay, integration, differentiation, continuous, that's crazy. But I have to let you know what are they, right? Because otherwise, why are you here, right? I mean, why I introduce this concept? Because every calculation, just click Excel button, it's done, right? So you need to understand what's going on. I hope. And as I said, right, the median grade for this class will be B+, right? So, and actually more than median, right? I mean, usually, right, in elite class like us, right, we will have at least, I would say, more than 60% or 70% people get B+ or above, right? And then you get B, maybe like at least 80% people would be or above, right? I mean, some people get B-, but that is historically like this, right? Because you guys are very good, so I don't worry about that. I mean, of course, if you don't do assignment, you don't do your project, then I can't help you, right? But otherwise, shouldn't be too difficult. A good question is when to use discrete, when to use continuous, okay? And the simple answer is when you're counting 1, 2, 3, 4, 5, number of success, right? How many people you come in this period, you can count things, right? It's discrete, right? Continuous is like stock price, right? It's continuous. How much profit you're getting, accounting, right? They are continuous, okay? And which is more convenient? Actually, it's very simple. When you work enough problem, then you know. I mean, it's very hard to say. I tell you, it's very abstract, right? I can tell you, but it's very abstract. Idea is like, actually, there's no difference between discrete and continuous. Usually, when we apply in practice, whatever is more convenient, more easier, then we use it, right? Just like you can ask, if you ask me, okay, if you try to cook a food, we use the pan or use microwave often? Depends, right? If the food is already cooked, we reheat it, then it's microwave often. If the food is not cooked, then you put in the pan is faster, right? It really depends on, or if your food is microwavable, then put in microwave often. Okay, you learn enough, then you know, right? You know when to give what, right? Suppose there's a girl, then you want to impress her, right? Then you would know whether you send her a flower, or send her a handbag, or send her something else, right? You know more about her than you know what to send, right? If you should like rose, then you send rose, right? If should like particular kind of plant, then you send that, right? So it depends on situation, and already tell you the answer, right? I hope. I think the answer is whether you run off to decom places, I don't think it matters for us. Regardless of the answer, I think test or assignment, I ask the TA to grade very loosely. So as long as it is not too far off, then you'll be fine, okay? I mean, it's 0.1, you 0.12, 0.11, or 0.13, usually it should be fine. I allow some error of the calculator, right? If 0.12, usually 0.3, then off is still off, right? We're not going to pick you up on that, right? If you fraction, of course, it must be related, similar, we convert to that common number and see whether it's, I mean, it's okay. It's not a math class, so I don't expect you to have perfect accuracy, okay? But cannot be too off, okay? Yeah, big F is measuring 2 point A and B. If you look at the probability A and B, it's big F B minus big F A. The difference gives us the probability in the interval. That's big F. Okay, let me repeat. Big F, the difference between two values, A and B, give you the probability. That is what it said. And the small f is just, don't know the difference. Look at the area between A and B. Under the small f is the probability, the same thing. Okay, so that is what you need to know. Okay, and as I said, don't worry. This is the thing we will repeat and repeat over the semester. So it's very hard you not know it. Okay. Yes, it's difficult because this involves some math, okay, some definition of math. And as I said, you know the example, then will be better. Okay, I hope that would be. Though to be sure is, we are not allowing you to bring the laptop, right? Because of cheating. But that means that you don't have to worry about calculation that require Excel, right? Then probably if I ever ask you, you just write the Excel function, you write the Excel formula, then you're done. Okay? So that actually make your life easier, right? Because you don't have to worry about the Excel. Okay? Whenever you need, probably you need know the Excel formula, you just write down the formula, then done. Okay? So since everyone have different calculator, then you don't expect our class the exam will not be very computational heavy. Okay, just applying some basic formula, then you're okay. Okay. In any case, you can write Excel formula. I you can go through. As long as formula is right, you can go through. Okay, so don't worry about that. I mean, we are not super crazy about the calculation. Okay, as long as you know how to do it, then it should be fine. Too much information. So as I said, you know for continuous, just know the big F and small f definition, right? Difference between F, B minus FA is probably B and A, right? Small f, we simply the area. That's something you know, okay? And of course, I give you more background why they are right and why we care, because the big P is not defined, right? Because continuous. So there's no number you can assign probability. So we have to resort to big F. And big F, our mind usually can't really handle the area difference. So easiest look at the small f, look at the area, our life is easier, because look at small f is same as the bar graph, right? Because the small f, if you recall our slide, okay? The small f and the p is very similar, right? Because the height of the p is the probability, right? And you figure out the bar graph, right? Just the area, the same idea, very similar. So that's why the big P and this small f is very similar, right? It's the idea-wise, it's very similar. I hope that would make you more comfort, but I agree that it's not easy. For me, it took me quite a while to understand what's going on. I mean, of course, you can do calculation. For me, it took me, I mean, I do all the problems, assignment, and after 1 year or two, I understand what's going on, right? Because my major is actuarial science, many of you would know, right? Basically dealing with probability. But after a long while, I understand what's going on here. Okay? I don't expect you to understand in one class. If you can do it, you're super genius, right? So don't expect yourself to be super genius. Don't feel stressed, right? Just sit back and relax, look the example, and then you do the assignment, and you will know what's going on. So you have to do assignment to understand what's going on here. So an assignment will be guiding you how to handle these problems. Interesting, right? We have someone thinks Friday. Yep, it's sunny. Yeah, this F. Yeah, it's difficult. I have explained already, because this involves new concepts, but we're using the same concept again and again, so you will know it. So that's not something that the two graph, small f and big F, is something we use. Because discrete, we'll say goodbye for the rest of semester. We will not touch. Yeah, we'll get the binomial, because binomial will be something we still use, but we'll keep the binomial and the normal, the bell curve, which we'll talk today. Okay, something that we'll keep. The speed is okay, not too slow. When people think I'm not following, well, so let me see the comment first. Oh, I don't know how to get this thing, but so first is I don't know what the sign means. We don't really need the differentiation or limit or interdifferentiation, because for those who know calculus, they know what's going on. Because those who know it's very natural. But if you don't know, it doesn't matter, right? Because look at textbook, they also give you the notation. I mean, but that's definition, right? You can't just like, yeah, it's okay. If you have some reason, you just let me know, and then you can attend the online classes. I do understand that everyone is very busy with everything. So, but this do remind you that our class is 4 credit. So please do the assignment. Okay. Oh. Wow. So this is a very nice, I don't know, I haven't been there, but someone recommend some nice food. I guess seeing nice food make you happier. Okay, but I don't know what does that mean. I think there's something like, someone suggests this restaurant. Good luck with that. But it didn't say anything is where. Oh. Oh, it's the suggestion is somewhere, I don't know where. I don't know where. You can take a look. Maybe this one. So this is a restaurant that recommended by some of your classmates, and you can try. I think it's reachable by the MRT station Kaifang. You can go to take the subway to there and then have fun. Okay. Hope you have a nice meal. So let's look at the other one. Oh, this is the canteen marks. Okay. There's a female who suggests the marks. Okay. But usually you don't know whether it's a boy or girl. Usually when they say this is usually a guy. But anyway. So they said this is a UC canteen, coffee corner, and cafe 330. And the Chongqi canteen is there. There's some canteen here. Yeah, so there's a list of canteen. I don't know if you agree or not, but something that you can take a look when you try. Okay. So so this is a discrete distribution, right? You look at the example. I think this is the reason why she put here, because if you only are able to put this category, it's discrete, right? If you give marks, 100 marks, 90 marks, 80 marks, it's continuous. Okay, I hope that would make sense. Okay. Usually I don't eat, so I don't really know. So you can ask your classmate. I don't have comment on that. So not sure. Because there's no canteen in B school, right? There's no canteen in B school. There's no canteen in the hospital. I don't really know. Whatever. But it seems like these days people, especially we have people in our group really like the United College canteen. Always commend that, so maybe you can try. Okay. So there are a lot of variables. So maybe it's good to give you some idea of example to make you feel more comfortable with continuous random variable, because look at all the definition looks crazy. Okay. So uniform is any number between A and B are possible. As I said, this is usually we do when we don't have any idea what's going on, right? Suppose I talk about a stock price, right? It's between 20,000 to 30,000 for Hang Seng Index A, right? Then you don't want to put any structure on the probability. The uniform is the most simple one, right? And the definition is this is the F and the small f, okay? And hopefully this would give you good idea what's going on, okay? The small f and big F, okay? I'm not going to do the proof, but let's see the following, okay? This is the big F, and this is small f. Okay? And when we say uniform, you expect that it means what? Uniform is, it means that you pick any length, fixed size of interval, say 1 or 0.5, whatever interval, the size, the area the same, all right? So that means that it must be the case that this is a straight line, okay? And the reason being that, okay, if you pick this area, right, the length is 1, say, okay, and you pick another area, this is also 1, this area must be the same, right? Because uniform means no matter where you pick, right, you pick the same length, it must be the same. Then it has to be a rectangle, right? And since this guy must be 1, right? The area must be 1, right? The area under F must be 1, right? So area you learn is the base times height, right? This is B minus A. What's the height? This is elementary school math. B minus A times what is 1? 1 over B minus A, right? So 1 over B minus A, right? So that's why F of X is 1 over B minus A. I hope this example would help you to understand what is a small f here, right? So if you try to ask, suppose A and B, make it easier, right? Suppose A is 0, B is 10, right? Say, just make it easier, right? In this particular case, f of X is 1 over 10, right? So suppose you ask, what's the probability between, say, X is between, say, 3 and 4, right? Then 3 and 4 will be just like this, 3 to 4, right? And the height will be 1 over 10, right? So area is what? Rectangle. The base is 1. The height is 1 over 10. And that's it, right? It's 1 over 10, right? So that would be the idea that how small f being used. I hope that is more intuitive. As I said, we are not math class. I'm not checking this thing for your assignment or your test, but just give you an idea what small f here. Okay, is that okay? So if you try to think carefully, if this is A, this is B, okay, it must be the case that this is 0 and 1 must be here, okay, and it must be the case this is a line, okay, and this line is just simply X minus A B over A. It just because if X is here, right, we calculate this area, right? It's X minus A times UA. That's it. That's how you get this formula, right? Because this height is telling you the probability. So it's you keep moving the X, this is the formula, it's linear. Okay, of course, we can integrate, that is what you get, but I don't want to do integration, right? So as I said, I'm not asking you to derive this formula. I'm not asking you to derive the formula. I'm just telling you that it can be derived, okay? And this is how I get the formula there, okay? It is never my intention to ask math, okay? Just know there's a formula and the formula given to you and that's it. Is that okay? So just to make sure that I'm not asking the formula. I do a whiteboard here because I try to convince you that this is something reasonable. Okay, you don't have to know how you derive this f, how you derive the big F. Okay, there's no need. Okay, but if you care why integration, I think it's more clear. And why that is the slope, because the slope is constant, so that's why it's constant. But anyway, this is the graph I have, right? You can see here. Okay, so and this integration definition, right? But only way to know is this guy, okay? The big F is X minus A over B minus A, so it's a definition, okay? And the only thing to remember, there's something probably not surprising. The mean of X is A plus B over 2, it's the middle, right? A and B over 2 is middle between A and B, right? It's the average between A and B, right? A plus B over 2, right? Because every number is there, the average is exactly middle. I think that is very intuitive. Okay. I think the only thing that's not intuitive is the variance. Okay. To prove it, you require calculus. Okay. But it's a fraction. Numerator is B minus A over 2, which is not surprising because B minus A is the range square because the difference. Okay. The only thing that puzzle you is still puzzle me still now is you divided it by 12. Okay, absolutely no reason. But if you look at the calculus, you integrate. That is easy to see why this is the case. But I don't want to bother you with that. But that would be something there. Okay, but it means that the bigger the range, the variance larger. Not surprising, right? Because variance how concentrated data is. It's the bigger range, the variance larger. And you need to know this formula. That's the only thing we need, right? So this is the slide that you need to remember. Uniform, right? Means every interval is the same, right? So I guess the green one is the thing you need to remember because you will be using it for your assignment, right? I ask something similar. We place some number there, you need to know, okay? I mean, this is very often when we go to observatory, the local weather forecast, right? They will say, okay, the rainfall will be between 1 mm to 4 mm today, okay? And then usually if you don't say the distribution, then it's uniform, right? That's usually what we assume, right? Then how can we calculate the mean and variance? That's something we care, right? On average, what is the mean and variance, right? And mean is very simple. It's A plus B over 2, right? A is 1 here, B is 4 here, right? The midway, right? And what's the variance? B minus A squared over 12, right? So it's just 4 minus 1 squared over 12 equal to 3 over 4. That's it. That is what we need. See, it's not complicated, right? That's what we need. Okay. I tell you it's uniform. You just apply the formula, and that's it. Okay. And I tell you so much stuff because I want to understand, try to understand, right? And it's not easy to understand, right? It takes time to understand what's going on behind. But I hope this will plant the seed in your heart what is behind probability. It will take a long time before you realize it. And I told you, right? After I take 3 to 4 classes of probability, I understand what's going on. I mean, it's not that easy. But of course, if you're smart, some of you will be very smart, you can understand right away. But it took me quite a while. So I think I'm average, right? So I guess on average, it will take a while to understand what's going on there. Okay. And in the meantime, you just need to know how to operationalize this before you truly understand what's going on. Okay. It will take a long while before you understand what's going on. But it works. So that's the formula. It works, right? We are like Newton and 9 Newtons. It works, right? Understand the logic, second step. Okay. The first step is give you this example, give you this exercise, you know how to operate. Okay. So the other example is how to use the big F. Okay. How to use the big F formula. X minus A over B minus A. Right? If you still recall, right? This example will just tell us how to use this mean and variance. We want to tell you how to use this big F, right? So basically the 3 things we teach you, then you learn how to do all the things, right? So uniform between 1 and 4. So the question is, what is the probability between 1 and 3? Okay. And between 1 and 3 is you can do it 2-step. Make it like less than 3 and less than 1. Right? And this is the first equal sign. And because truly continuous, so whether equal to 1 or not doesn't really make a difference. You can replace that because that's probably 0 event, right? And less than or equal to is the big F. So F for 3 minus F for 1. Okay. And then for 3, just apply the formula. F for 1 to put the formula there. That's 2 over 4. Right? That's it. Nothing new. I hope that would be okay. I mean, that's not something too terrible. But if you look at the first principle, right? If you don't remember the formula, easiest to think is like this, right? X is between 1 and 4. Right? What's F here? And the height must be 1/3. Right? Because the base is 3, the height must be 1/3, right? 3 times 1/3 is 1. So the question is between 1 and 3. So the question is asking 1 and 3, right? Is this area. Right? And 1 to 3, that's 2, right? So 2 times 1/3, 2/3, that's it, right? If you don't like all the crazy math, just draw a picture, then you're done, right? So that's how they're related, right? I mean, it's not something complicated, but of course, you can just apply formula without thinking, then done. But if you want to understand the logic behind this, behind here, okay? The graph is not required. I mean, I draw the graph because if you want to know more detail, this is the graph you want to know, but it's not necessary. Is that okay? Is that okay? Is that okay? I understand today we are a little bit mathy because, as I said, this is the if you learn in my time, this is the last class for the first course of statistics. Usually, you go to stat department, this is the last class they teach. Okay, but of course they go to more deep. But usually the stat class ends here. I mean, ends this week, right? After continues the bell curve, and that's over, right? So that's why it is complicated, and because they are very useful by itself, right? Because you can try to figure out what's the distribution of what we're going to discuss, and then you can apply the formula, can answer a lot of questions, right? So by construction, it's difficult. Is that okay? It's not easy if you never understand, if you never heard about random variable. It's something like, aha, that's difficult. True. I don't want to pretend it's easy. Okay. So this is another example just to make sure that you understand, right? Is what is the rainfall between 2 mm and 3 mm, right? Of course, you can calculate this is f of 3 minus f of 2. Then you can look at this one is 1/3, right? But if you understand the logic we discussed, right? And you will say x is between 1 and 4, the small f, this is 1/3 here, right? Between 2 and 3 will be just this, 2 and 3, right? This area, the base is 1, the height is 1/3, 1/3 done, right? Of course, you can use f of 3 minus f of 2, which you can do it, right? So f of 3, right, will be 2/3. F of 2 would be 1/3, then it's still 1/3, right? One way or the other, right? Because f of 3, right? What it's calculating is this guy, right? F of 3 is just the red one, right? F of 3 is 2/3, right? The base is 2, right? And you can also calculate the f of 2 is this guy, right? F of 2 is this guy, right? The difference is the red minus blue is the green, right? Either you do one way or do the other. That's no different, right? Is that clear? Is that okay? I mean, as I said, pretty sure that you can't 100% understand. If you do, then you're genius. Let me know. I mean, you should study grad school. You should do a PhD, right? I mean, otherwise, you shouldn't be. If you never learned before, you can learn immediately. Then you're a genius. Okay, you should go to a more elite program. Okay, I can write you a recommendation letter for your scholarship. I mean, that is not that easy. I would say, right? If this class is so easy, you will not be for credit class, right? It's something you need some effort. Okay, you need some exercise to work. Okay, is that okay? So last, I guess it's almost time, but what I want to say is, I just said that, is remember the Poisson, right? Poisson asking in a period of time, how many people come, all right? And exponential is the same setting, but asking how long before now and the first arrival customer, okay? That means that you are modeling the time until something happened, okay? That is very normal, right? How much time before things happen, right? Maybe used in insurance very often. Well, when is the next typhoon is coming, right? This is something that we will do, right? And the formula, which I will not prove, will be look like this guy, okay? I'm not going to do anything on the math, okay? Because this is just Poisson. But at the end, I want to show you, okay, we'll come back. These are the crazy formulas on Wednesday. And then, the F is exponential, look like this decay, okay? But it's like the exponential is also the radioactive thing, is also like this, okay? The nuclear weapon, something like those kind of stuff. But I don't want to talk more. Let's have a break, and then we will see you on Wednesday, okay? Enjoy the day. Just a reminder, the assignment is going to be due in 3 to 4 days, right? 10th of October, okay? So I see you on Wednesday.
Also. Also.
Yes. When you have curly bracket, that means that there's a set. This is saying that equal to or less than. I'll talk. Can you ask this in the maybe you can ask in the you reply next time, because I can answer that again. Is that okay? Yeah, you can ask me in the you reply, I can do that.